Okay, this lesson is about area of circles, and hopefully you've just seen a little video about why the area of the circle formula is as it is. We're really thinking about splitting up the area of the circle into reordering it into a rectangle, and therefore we can come up with this interesting formula that the area is pi times the square of the radius, where we're still using pi as that figure is 3.1415. So there's our formula for the area of a circle, and we can use that in the same way as we use the area of any shape. The key thing here is that we're using the radius as our principal dimension here. If we get given information about the diameter, we know we have to half it, because the diameter, as just a little reminder, is the distance from one side of the circle to the other through the center. It's double the radius, so the diameter is twice that. So in the first example, to calculate the area of these circles, we identify, of course, it is a circle, so we can use the area formula. Area equals pi times r squared. And we substitute in, we're trying to find the area, so we keep the a. Pi we're going to use as 3.14, unless we're asked to keep it as an exact value, but for the moment 3.14 will do. The radius here, well, 6 is definitely the radius from the middle to the edge, therefore the radius is 6, and we can put in, you can either put in a wee 2, or you can just write out 6 times, or 6 multiplied by 6. You can do the whole calculation if you want. And then you can take a calculator if you have one. 3.14 multiplied by 6 again, and we get 113.04. We might usually round that to 3 significant figures. Quite often, see pi here, 3.14, there's 3 figures in that number 3.14, so we call that 3 significant figures. And so because we've rounded pi to just 3 significant figures, there's no point in giving an answer which is more detailed than that, because we can't be sure that that's any more exact. So what we usually do with pi is we round it to 3 significant figures. We only give the first 3 digits. In this case, the 0 that we're going to cut tells us to round down. So area is 113 square centimetres. Okay. You can have a go at the second one yourself. Pause it, have a go and check my answer. Okay, hopefully you spotted that 25 is the diameter. So that when we write out the formula, A equals pi r squared, hopefully you'll realise that we can't put 25 in because D is the diameter, r is half that, so that would be 12.5 or 12.5. Okay, so we do 3.14 multiplied by 12.5 squared, and we can again use a calculator. 3.14 times 12.5 squared is 490.625, and so on. As I just said there's no point in us giving any more detail than just the first 3 digits. So A equals 4. Now what do we say? 6 tells us to round up the last digit there, so it becomes 491 square centimetres. And we should really write to 3 significant figures. Okay. So that's how we work out the area of a circle. It's as straightforward as that. The only thing you have to work out is the information I'm given, the radius or the diameter. Okay, let's have a look at a wee bit of working back then. We can still use the formula. The area of the circle is 35 square meters. Calculate its area. Okay, that's not actually meant to be area, of course. It's meant to be radius to 1 decimal place. So this time we're still thinking about area and radius, and we have a formula that connects the two, so we write it down. Area equals pi r squared. So this time we've got 35 as the area, so that goes under A. We know that pi is 3.14, and this time we don't know what the radius is, and so we have to keep that as r. That's the thing that we're looking to work out. So like on all algebra, we want to get the letter on its own. So we want to somehow undo the times 3.14. So we divide by 3.14 on both sides. What does that give us? On the right hand side, they're going to cancel out. So I've got r squared. And on the left hand side, with my calculator, 35 divided by 3.14 is 11.146. I'll keep that for just now, just because I've got it's not my final answer. Now I have to undo the r squared term. We undo a square expression by finding the square root. Okay, so we do that to both sides. That means that the square cancels out with the square root, and we're left with r. And on the left hand side, we've just got the square root of 11.146. So use the square root button on your calculator. 11.146 gives me 3.3385. 3.3385, and so on. So we can flip that around to get r. I'm going to round it to, it says to 1 decimal place here. So there's 3.3. The 3 tells me to round down. So r equals 3.3 meters to 1 decimal place. So if you're looking to work back, then we can just use our algebra skills in doing all that. And just another wee problem solving question about area. It says 4 congruent circles are cut from a square sheet of metal 30 centimeters long. What area of metal is left over? That's the kind of grey bit, I would imagine. So congruent means identical, exactly the same. Are cut from a square sheet of metal. So we've got a square 30 centimeters long. So if that's 30 centimeters, then so is that. And there's no other dimensions given. That's because you could see here that the circles touch the edges of it, which means that the width of 2 circles together is 30, which means that the width of each individual circle is 15 centimeters. And the same can be said of the height of them. But effectively what we're discovering here is that the diameter of the circles are all 15 centimeters, which means that the radius is 7.5 centimeters. I've shown all that, I've worked that out in my diagram, so hopefully if someone else were to look at it, they could understand how I managed to get the fact that I'm using 7.5 centimeters as my radius. So we've got a circle. We could say the area of the circle. Now I'm going to put a little area and a wee circle to show that I'm working on the area of the circle. Is pi times the radius squared. 3.14 we'll use, and the radius I've just worked out is 7.5. We need to square that. Take my calculator. 3.14 times 7.5 times 7.5, and I get 176.625.6. And so on, but we don't really want the rest of it. We want to work to 3 significant figures. The 6 tells us to round up, so we're going to go with 177 square centimeters to 3 significant figures. That's the area of 1 circle. What's the area of the whole, the area of the square? So I'm going to put a wee square shape down at the bottom there. Area of a square is length times breadth, or length times length. Doesn't matter which of the 2 formulas you use. It's a rectangle as well. So we've got 30 times 30, which is 900 square centimeters. So we know the area of the whole square is 900 square centimeters. We know the area of 1 circle is 177. But of course there's 4 of them. 1, 2, 3, 4. So the metal left over, area left over, is going to be our area of the square, which was started with at 900, subtract 4 times 100 out of the area of the circle. I don't really need the brackets there because the order of operations would say do that, but visually it helps us to remember that there's something going on. So it's 900 subtract 177 times 4. 4 lots of 177. What's that? 354 That would be 354, 708. 708. And if I subtract that, I'll get 8 less than 200, which is 192. Or you could do a wee calculation at the side, and so on. Okay, area left over is 192 what square centimetres. And I've already put some words, I'm not going to rewrite my conclusion, but if you hadn't, then you might want to write a wee sentence at the end. So that's it, that's how we work out, we're using area of a circle. Sometimes you've got to do a wee bit of working to find the diameter or the radius to help you then solve the problem. Okay, I hope that's been helpful, and you can go on and work on that.